So in this case, we will discuss about the 12 principles of green chemistry. The first principle, it is called the waste prevention. Waste prevention means we have to minimize the production of waste in any chemical reaction. Like we can say that the prevention is better than cure. So that the before we will start design any chemical reaction, we have to design in such a way that only product will get formed. We can minimize the production of byproduct, so that we will not put the extra effort to convert the byproduct into the product. The second principle is called the atom economy. The atom economy means the economic process. Suppose that any reaction we want to do in the laboratory, in that whatever the chemical components required in the reactant, they should all get converted into product. That is called the economic process. Means the suppose that if we want to start any reaction from 100 gram, suppose we want to start any reaction from 100 gram of the starting material, and that 100 gram should get completely reflect into the product. That is called the economic process. So here we can say that the percentage of yield we can able to calculate it, like the percentage of yield equal to the actual yield of the product multiply by 100 divided by the theoretical yield of the product. By using this formula, we can able to calculate the percentage of yield in the reaction, so that we will know that how much amount of product is getting formed, so that we can minimize the production of waste in the chemical reaction. Now the next principle is called the less hazardous chemical synthesis. So in the less hazardous chemical synthesis means we should not use any chemical component in the reactant which should be hazardous in nature. I mean which should be toxic in nature, so that we can minimize to use of chemical reagent in any reaction. So you can read this point: whenever practicable, synthetic methodologies should be designed to use and generate substances that possesses little or no toxicity to human health and the environment. So it is very important we should not use any toxic chemical component in the reaction mixture, so that it will cause the problem or create the problem to our atmosphere or the environment or the human being or the animals. So this is called the less hazardous chemical synthesis. Now the next point, it is called the designing of safer chemicals. We have to always design safer chemicals. Suppose that we want to do any reaction, so we should not prepare any product which should be toxic in nature. So that we have to always synthesize such type of chemical compounds which are those are eco-friendly and biodegradable in nature, so that they will get self-degraded under atmospheric condition. So this is called the design for safer chemicals. Now the next point, it is called the safer solvent and auxiliaries. You know that safer solvent, this is very important. It is also called innocuous reagent. Innocuous means harmless reagent, means which the reagent which will not cause any problem to the human being or the animals or onto the aquatic life. So they are called the safer solvent or the safer auxiliary, or we can say that the innocuous reagent, or they are called the harmless reagent. So these harmless reagent are what? Basically, we can say that the safer solvent in our regular life, we are using one very important solvent, that is called the water molecule. As you know that we are regularly drinking it, so that the toxic component can be released from our human body. So that is called the safer solvent. So the safer solvent, particularly, they are the non-toxic in nature. They are not creating any problem to our atmosphere, and they are self-degradable material under atmospheric condition. Like the example, I will say that the water molecule, and you also knows the ethanol. As last time we have discussed about the power alcohol and the bioethanol. So bioethanol means the ethanol which we have produced by fermentation process, that is called the bioethanol, and it is the renewable resources we are getting or generating from the renewable feedstock, like the sugarcane bagasse, or from the byproduct of the sugar industry, that is called the molasses. From there we can able to produce the bioethanol. So this is the safer auxiliary or the safer solvent. Some other solvent also important, like we can say that, as you already knows that the acetic acid, that is also coming from the safer, from the renewable resources. And you know that apart from that we can say that some other region, like we can say that the methanol, ethanol, water, and acetic acid, they are eco-friendly in nature, and they are not causing any problem to the atmosphere. They are getting self-degraded, hence they are called the safer auxiliary or safer solvent. Now there are some other toxic reagent or the toxic solvents, like almost all the organic solvents, they are the toxic in nature. The example is benzene, chlorinated solvent like chloroform, carbon tetra carbon tetrachloride, and the dichloromethane. These are the chlorinated, and the aromatic hydrocarbons are toxic in nature because of they are carcinogenic in nature. They will cause the cancer to the human body. That's what we have to uh,
Yeah.
avoid to use it.
Ah.
So we will say that the such type of organic solvent, the aromatic or the aliphatic halogenated chemical solvents, we should say no to use, so that we can prevent our atmosphere and we can prevent our body from the cancer. Now the next is called the design for energy efficiency. That is the sixth principle. It is called the design for energy efficient process. So you know that the energy efficient means we can minimize the energy of any chemical reaction. It means that whatever the reaction we want to design in the laboratory, that should proceed under ambient temperature and ambient pressure. Means we have to do reaction under at room temperature and 1 atmospheric pressure. It is called the ambient temperature and ambient pressure, so that we can minimize the energy required for the chemical reaction. So this is called the energy efficient process. As I will give you one example, you know that the benzoic acid, last time we have already discussed about the benzoic acid react with ethanol in presence of acid catalyst to produce the ethyl benzoate. Now this reaction taking 24 hours to complete at 100 degrees centigrade temperature. So now this 100 degree centigrade taking 24 hours, it means that it required huge amount of energy. So how to minimize this temperature and the duration of the reaction? So that what we will do, we will take the, we will basically do reaction under the same reaction we can do under microwave condition. So in the microwave condition, the same reaction will get complete within 10 minutes, and it require 100 degree centigrade temperature. So that now you can think about almost 100% of energy we have saved because of under microwave condition, reaction is getting completed within 10 minutes. So if the normal reaction is taking 24 hour at 100 degrees centigrade, the 24-hour energy we can save it if we can proceed the same reaction under microwave condition. So this type of reaction is called the energy efficient processes. Now the next principle, it is called use of renewable feedstock. So generally we should, in this case of use of renewable feedstock, this is very important. You know that the renewable feedstock, in this case we have to avoid to use such type of feedstock which will not be the renewable feedstock. So here we will use, suppose that we are generating the bioethanol, or we can say that the biodiesel. In all the cases, we are uh, using the renewable feedstock. Like in the case of biogas, that is called the natural gas. It is also called methane. For that, we are using the cow dung, that is the renewable feedstock, or we can use the vegetable waste vegetable biomass, or we can use the plant leaves for the renewable feedstock to generate the biogas. Similarly, you know that we can generate the bioethanol by using the molasses, which is the byproduct of the sugarcane industry, and we can use the sugarcane bagasse, or we can use it the starch and cellulose for the conversion of bioethanol by fermentation processes. So these are the renewable feedstock. Other than that, you know that the biodiesel can be also prepared from the renewable resources, that is called the, we can say that the plant seed oil, that is also known as refined, and it is also called the triglyceride. Triglyceride undergo trans-esterification reaction with the methanol to produce the biodiesel. So these are the renewable feedstock. Generally, we have to apply the renewable feedstock so that we can generate the less hazardous material to our atmosphere. So you can read the definition. A raw material or feedstock should be renewable rather than depleting whenever technically and economically practical. Now the next point, it is called the reduce derivatization, or we can say that minimize derivatization. Means any chemical reaction, suppose that running in 4 to 5 steps, if we can complete within 2 to 3 steps, this is called the reduction of derivatization or minimization of derivatives. So you know that any chemical reaction required protection, deprotection chemistry, or the blocking group for the temporary modification, so that we can avoid to use such type of protection, deprotection chemistry, and we can complete reaction within 2 or 3 steps, that can be minimized the derivatization, and it will be the good reaction condition because of the less amount of chemical we have used, and it will generate lesser amount of hazardous material to our atmosphere, so that the reaction will be efficient if we can complete in 1, 2, or in 3 steps, not more than these steps, so that we can minimize the derivatization. Now the eighth principle, now this is completed the eighth principle. Now next it is called the ninth principle. This is called catalysis. This catalysis is one of the very good principle of the green chemistry. As you know that using the catalyst in any reaction, that will make the energy efficient reaction, because of the role of catalyst is to increase or enhance the rate of reaction, so that the reaction will take lesser time to complete. Next point, it can also reduce the temperature of the reaction. It can also reduce the time of the reaction. And after completion of reaction, the catalyst can be recovered back. so that that catalyst can be further used in the next iteration. So this is called the catalytic process. Okay, catalytic reagents are superior to stoichiometric reagents so that they will increase the yield of the product. So this is called the catalysis. So the best example of catalysis, you know that the vegetable oil can be converted into the vegetable ghee. You know that the vegetable oil that is called the refined. So that refined is the unsaturated fat. So the unsaturated fat, if we can convert into the saturated fat, basically we want to reduce the double bond present in refined or the vegetable oil under hydrogenation condition. So if we want to do the hydrogenation of the vegetable oil, then what we have to do, we have to use the nickel as a catalyst and hydrogen as a gas. So under nickel catalyst, we can, or the under iron catalyst, we can reduce the double bond to convert into the saturated fat that is called the dalda or the vegetable ghee. So these are the catalytic process for the conversion of chemical synthesis. So this is the one of the very good practice to use the catalysis in the chemical synthesis. Now the next point or the next principle, that is 10, it is called the design for degradation. So design for degradation means we have to use such type of biomaterial which can self-degrade it under atmospheric condition. So this is called design for degradation. I mean, we have to design such type of product or the reagents or the reactant which can get self degraded under atmospheric condition, and they will be harmless to the environment. So this is called the design for degradation. Now the next principle, it is called the 11th, the waste prevention, pollution prevention. So the pollution prevention, we can prevent pollution. How? So you can read that analytical methodologies need to be further developed to allow for real-time in process monitoring and control prior to the formation of hazardous substances. So the pollution prevention means we should not generate any hazardous substances to the atmosphere so that it will cause to the problem in our regular life. So that we have to use such type of reagent or the product which they are the eco-friendly in nature and they are non-toxic, they will get self-degraded under atmospheric condition, and so that we can minimize the pollution prevention. So always we have to use the renewable resources that can be minimize the pollution in the atmosphere so that we can prevent the pollution in our atmosphere. Now the last principle, that is called the 12th, it is called the safer chemistry for accident prevention. So the last principle, it is called accident prevention, means how to minimize the accident in the laboratory or how to prevent accident in the laboratory. That is the 12th principle. So in this principle particularly, as you know that the laboratory practice is very important. If we want to work in the laboratory, in chemical laboratory, we have to first learn few points so that you will have the training and then we will start working with chemicals. So in this, the healthy practice is that you should get the training in your hand. So in the training include means what type of chemicals present in the laboratory. Like there are two type of major category reagents. One is called the oxidizing reagent and another called the reducing reagent. So the oxidizing reagent always keeps separate from the reducing reagent. If we will mix together, then what will happen? The fire hazards can created because of the oxidation and reduction reagent. They will mix together to generate huge amount of energy, and that will cause the explosion in the laboratory. As the one of the best example, I would like to explain you, when the hydrogen balloon we will burst in the atmosphere, it will create huge amount of energy with sound. So you know that the hydrogen is a reducing reagent, whereas the air present in the atmosphere, that is the oxidizing reagent, when they will mix together to generate the explosion. So here it is causing the accident. So we should always keep segregate the oxidizing reagent and the reducing reagent in the laboratory. So these are the 12 principles of green chemistry. By following these 12 principles, we can minimize the hazardous waste production in the atmosphere. So thank you all for having patience.